Hi, welcome to this lesson on trigonometry compound angles. Let's have a look at question 1. So when I solve for x in the interval 0 degrees to 360 degrees, if we are given that sine x times cos of 30 degrees plus cos x times sine 30 degrees equals a half. So now, the structure of this equation looks very familiar. We have sine cos sine of those two angles, x degrees and 30 degrees. So this brings to mind that this is sine of x, and because of the sign in the middle, it stays the same, 30 degrees. Okay, so I can reduce that expression using compound angle formulae, because that'll become sine x cos 30 plus cos x sine 30, if I expand out this using the compound formulae. Okay, that's equal to a half. So now we just have one trigonometric equation that we can solve. So now we can follow the standard procedures for solving a trig equation. So I'm going to need my cast diagram ready. Okay, and the number on the right is a positive number. So that means where's sine going to be positive in the first and second quadrants. So first of all, I'm going to have x plus 30 degrees. This needs to equal a reference angle. And the reference angle is going to be sine inverse of a half, which is 30 degrees already. So that's my reference angle, 30 degrees. So therefore, my two solutions are x plus 30 degrees, the angle, must either equal 30 degrees plus k times 360 for the period of sine, or in the second quadrant, x plus 30 degrees must equal 180 degrees minus 30, so that's 150 degrees, plus k times 360 degrees, where k is an integer. Okay, so this simplifies down to, if I subtract 30 degrees on both sides, it's just x equals 0 plus k times 360 degrees, but I'm not going to write 0 because it's implied if you're adding 0, it doesn't change. Or x equals, so if I subtract 30 degrees here, it's x equals 120 degrees plus k times 360 degrees. Okay, and again here, k is an integer. So these are the general solution sets, and we want between 0 and 360. So for the first quadrant solutions, if I put k equals 0, I get x equals 0 degrees, which is inside that domain, so it's fine. If I put k greater than or equals to 1, well, at 1, it's going to be 360 degrees, which is fine. But anything bigger than 1, you're going to get 720 and so on, so we can't use those solutions. And then in quadrant 2, if I put k equals 0, I get x equals 120 degrees. All right, and that's fine, it's in that interval. If I put, for the first quadrant, if I also put k less than or equals to -1, right, because that's also integer values, I'm going to get negative values, so it's less than 0, so there's no applicable solutions here. Then k greater than or equals to 1, well, at 1, you're going to have 360 plus 120, that's 480, definitely outside the domain, so any solution greater than or equals to 1 will not be applicable here. Similarly, 120 minus 360, that's going to be negative 240, which is less than 0 degrees, so there's going to be no solutions for any negative integer parts. So the only solutions are x equals 0 degrees, x equals 120 degrees, and x equals 360 degrees. Okay, and if we plug in those values into here, we should get a half. So we can double check and just see that we've done it correctly. So I'm in degrees mode. So the equation we're referring to was sine of the angle plus 30 degrees, and that must give us a half. So the angles we worked out were 0, that gave us a half. We worked out 120 degrees, that gave us a half, and we worked out 360 degrees, and that worked out to a half. So those are the three angles in that given restricted domain that will satisfy this most original equation here. All right. I'll see you in the next one.